A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third seconds? Now, the first thing we are going to do is to bring out our parameters from the question. So that is, a body starts from rest. Now, whenever you see this rest in a question, it means that your initial velocity is equals to 0. So you quickly write u equals to 0. Nobody is going to tell you, you should know. So now, and moves with uniform acceleration of 6 meters per second square. Now, it means that your acceleration A is equals to 6 meters per second squared. What distance? You're asking a question, what distance? So it means that you don't know the distance. So our S is not known because the question is what distance? So the question is asking us that. Now, does it cover in the third seconds? Well, let's say our time is 3 seconds for now. So our time T is equals to 3 seconds. Now, the next thing is that you're going to select one of the equations of motion that you're going to use. Now, which of the equation, please, once you have brought out your parameters, look at the equation of motion that has all your parameters, and that is what you're going to use. So now, from here now, we can see that this is the equation that fits our parameters. So we are going to use this equation. But now you need to understand this question. The question asks for distance it covers in the third seconds. In the third seconds. Now imagine something starts from 0 here like this. At this point, and move for 3 seconds. It moves for 3 seconds. So this is the distance is covered for the whole of the 3 seconds. Now, if the same thing moves from here like this and moves for just 2 seconds here like this. Now, this is 2 seconds. Now, this is the distance it covers for the 2 seconds, for the whole of the 2 seconds. Now, the question is now asking, what is the distance it's covered in the third seconds? Meaning that this is between these 2 and 3, that is the distance it moves in the third seconds. And that's what we are looking for. So, meaning that if you know the distance that it covers for the whole of the 3 seconds, and you know the distance covered for the whole of the 2 seconds, you can just subtract the distance covered for the whole of the 2 seconds from the whole of the 3 seconds, and you're going to have your answer, right? Remember that we said we are going to use this second equation. So our S is equals to ut plus half at squared. But there's one thing. Here, our u is equals to 0. So if I put 0 here, this will always be 0. So I'm going to say this goes to 0. So I'm going to say S equals to half at squared, right? Because this u is always 0. So this part is not necessary, right? So now this is what we are going to use. So we are going to look for the distance, whole of the distance when the time is 3 seconds. So that is going to be S when the time is 3 seconds is equals to half times our acceleration is what? Is 6 times when the time, what's our time now? 3 seconds, right? But don't forget, it is t squared. So it has to carry square like this. So 2 here 1, 2 in 6 is what? Is 3. So 3 squared means 3 times 3, that's 9. Then 9 times 3 is going to be 27. That's 27 meters. So it means that from here to here now, it is 27 what? 27 meters. Now, S, we are going to look for the distance is covered for the whole of the 2 seconds. So that's going to be when the distance when the time is 2 seconds is going to be half, right? See this equation, times our acceleration is still what? 6, times our time is what? Our time is what? Is 2 now, right? It's 2 now. So that's going to be 2 what? 2 squared because of this squared, right? So 2 here 1, 2 here what? 2 here 3, right? So 2 raised to the power of 2 is 4. It's 2 times 2, 4. 4 times 3 is going to give us what? 12, right? So that's 12 what? 12 meters. So it means that from here to here now is what? Is just 12 what? 12 meters. So if something from here to here is what? Is 27, and from here to here is what? 12. So from here to here will now be what? 27 minus what? 12. So that's going to be equals to S what? S, the distance when the time is 3 seconds minus the distance when the time is 2 seconds. So that is going to give us the distance is covered in the third seconds. So that third second is just like the last 1 second. So here that's going to be 27 minus what? Minus 12. And that is going to give us what? That's going to give us 15 meters.